Okay, in this video we're going to talk about writing and using geometric, recursive, and explicit formulas. So in the first example, we're going to consider the recursively defined geometric sequence a sub n equals 3 times a sub n minus 1 with a sub 1 equal to 2. Well, when we see this a sub n minus 1, again, remember that just means that that's the previous term. So to determine the value of a sub 4, since this is a recursive defined, we need to use the previous to then find the next one. So in order to find a sub 1, they gave it to us, a sub 1 equals 2. So then to find a sub 2, we just plug in the previous term, which is 2, in place of that previous term, so 3 times 2, which equals 6, and then to find a sub 3, with that previous term, we just sub that in place of the previous term that we saw. So you can see here that we're multiplying by 3 each time, but what we're multiplying by is always the previous term. So that's what's changing. And then we get that 54. So that's how we do a sub 4. We need to do the previous each time. So how many times was 2 multiplied by 3 to make a sub 4? Well, the 2 was multiplied to make it 54. It was multiplied 3 times. So 2 times 3 times 3 times 3 to give us the 54 in order to get a sub 4. So how many times? 3 times. And now we need to use this idea from part B to find a sub 9. Well, if we want to use this idea of multiplying by 3 times here, we're going to multiply it 8 times here. So we can write it out that long way, or remember when we do repeated multiplication, we can do that to the 8th power. So now we need to write an explicit formula using a sub n for this sequence using a sub 1, d, and n. So we can write that as a sub n equals a sub 1 times r to the n minus 1, or in this case, a sub n equals 2 times 3 to the n minus 1. So what else does this sequence formula look similar to, and what type of function does this sequence represent? This looks similar to an exponential function because it's raised to an unknown power. So I wrote out there, this geometric sequence formula looks similar to an exponential function because it is raised to an unknown power, so we have that y equals ab to the x power. Now remember, just like with the previous, we are given the geometric sequence formula on your formula sheet. So the geometric sequence formula, a sub n equals a sub 1 times r to the n minus 1. To write and use this rule to any nth term, you must know the first term, a sub 1, and the common ratio, r. So given the sequence, -2, 8, -32, 128. What type of sequence is it and why? Well, if I look from one term to the next, what are we doing to get from -2 to 8 to -32 to 128? I can see that I'm multiplying by a -4 each time, so that means that it's going to be a geometric sequence, and that's because it has a common ratio. So I said geometric sequence because r equals -4. So write a recursive formula for this sequence. Well, what did we do each time? Remember the recursive need 2, so I can start off with a sub 1, the first term, which they gave us, is equal to -2, because that's what we started off as. And then to find a sub n, which was any given term, then I can use the previous term, so a sub n minus 1, which again just means previous term, and then multiplied by -4. That'll always give me the next term. Then it says write an explicit formula for this sequence. Well, now I'm going to use that formula that's in the big box above. So to find a sub n, I'm still going to write a sub n, and remember that these should be used for any term, so I don't need like a previous term, just one explicit easy equation. So a sub 1, which was -2 here, so I'm going to put that in for a sub 1, times r, which is the common ratio of -4, and then raised to the n minus 1 power. And then determine a sub 11. To do that, we just fill in what we know into the formula, and I'm going to actually leave that one for you just like I did in the previous one. So just use the explicit because that's easier than using the previous and finding the next and finding the next. That's going to take a lot longer. So since we're just looking for a sub 11, I would use the explicit nice and easy formula, plug in what you know and find it, and then describe what that means in words. All right, we'll see you tomorrow.